In this video, I'd like to talk about using arithmetic sequence formulas, or essentially writing these arithmetic sequences as functions. So before we look at the two different types, the recursive and explicit formulas for these sequences, let's just talk about the notation in general. So let's say we have some arithmetic sequence, maybe as an example, we can look at 5, 10, 15, 20, and so on, where in this case, we can find that common difference of 5. Since notice that from one term to the next, we are adding 5. Now, we could write this as a function using a formula, or in fact, we can use two different ways of representing it as a formula. So let's call it a function a of n, where n is our term number. So for instance, 5 is the first term. So let's write this out as a table where we have n and a of n. This is just our function. So when n is 1, our function for this arithmetic sequence would give us back 5. So this is a of 1 is how we would write it. When n is 2, we're talking about term number 2, which is 10 in our sequence. And we would write this as a of 2, since this is essentially saying what is the second term in our arithmetic sequence. So just to continue this, when our term is 3, we're looking at 15. When our term is 4, we're looking at 20. So 20 is, in other words, a of 4. It's the fourth term of our arithmetic sequence. So if we wanted to ask what is maybe a of 6, well, we could extend this further. It would go 25, then 30. So it looks like, in this case at least, a of 6 is 30. The sixth term in this specific arithmetic sequence is 30. So like I mentioned, these are functions of the term number. And these functions, their domain is specifically only covering the integers or the positive integers. In other words, we call these the natural numbers. And we're going to look at two different ways to write these arithmetic sequences as formulas. The first one, as you can see in this example, this is called a recursive formula. And a recursive formula is basically going to tell us what the first term is, and then it's going to tell us the pattern. So this notation might be a little bit confusing at first. So a sub n, or a of n, there's another way you can write this. You might see it as a sub n, like that. Whereas this a of 6, sometimes it's written as a sub 6. But this a of n, this arithmetic sequence, at term n is equal to the arithmetic sequence at term n minus 1 plus 4. So this particular term right here, this is the term before the term you're looking for. So for instance, this formula essentially just gives us the pattern for how this sequence is going to work. To find the next term, you're going to take the previous term and then add 4 to that. So they give us that a sub 1, or a of 1, is equal to minus 13. So our first term here is minus 13. So to find our second term, we're going to need to look at the first term. So plug in 2 here, 2 minus 1 is just 1. So it's the first term plus 4. And we know the first term is minus 13. And so we'll add 4 to that, and we get minus 9. So the second term of our sequence is minus 9. And if we want to find the third term, now we're choosing n is equal to 3. So plugging 3 into this, you get 3 minus 1, which is 2. So now we need the second term, and we're going to add 4 to that. Well, the second term is negative 9. And then we add 4 to that, and we get minus 5. And of course, you can keep going here, but you probably see the pattern. We're just adding 4 to the term before it. So to find the next term, we take the previous term and then add 4. So minus 1, we add 4 to that, we get 3. Add 4 to that, we get 7. and so on. So these recursive formulas will give us the starting term, and then it will give us the pattern. And from that pattern, we can generate the rest of the sequence. So the next formula type we'll look at, these are called explicit formulas. Or in other words, we will just call this the explicit formula. Now, these formulas are useful if we want to find a term that's maybe really high up in the sequence without having to generate the entire sequence. So for this one, we can just plug in n equals 9 into our explicit formula. So we're finding this arithmetic sequence at term 9. So b is our particular arithmetic sequence here. So we want b of 9. And all we do is plug 9 in anywhere we see an n. So we have minus 8 minus 2 times by 9 minus 1. And simplifying this, let me make just a bit more room here. We would have minus 8 minus 2 times 8, if we simplify the parentheses. So this is 16, so we get minus 8 minus 16. And minus 8 minus 16 would be negative 24. So it looks like the 9th term in this sequence is minus 24. Now, these explicit formulas, we can think about them more generally. Let's say we have some other arithmetic sequence. We can call it C of n. And to find the nth term in that sequence, basically you start with your first number. So minus 8 is the first term in the sequence. Since if you plug in for term 1 here, this term right here becomes 1 minus 1, which is 0. So your first term is always the term in this formula that's not connected to n. So we can say it's C of 1, the first term in our sequence, and then plus the common difference multiplied by n minus 1. And the way to make sense of this is that in all of these arithmetic sequences, you start with some number and then you add the same number a bunch of different times to generate the next terms. So for us, to find this 9th term in the sequence, we started at minus 8, and then we subtracted 2 8 more times. And you can see that in the formula. We subtracted 2 times 8. So that's representing doing that 8 different times. So for all of these explicit formulas, it's going to be the first term plus d for common difference multiplied by n minus 1. So as another example here in this problem, let's say we're trying to find the 6th term. So we would find b of 6. And so we start with that first number, and then we're going to subtract 2 5 more times. So it'd be minus 2 times n minus 1, or 6 minus 1, which is 5. And minus 8 minus 10 would be negative 18. So if it helps, you could generate the entire sequence yourself, but we can notice these patterns, that it's always your first term plus the common difference multiplied by n minus 1. So this is our general formula, but in these practice problems, we're going to look at some specific examples. So we can also look at a more general formula for this recursive formula. And let's say we're looking at some arithmetic sequence, which we'll call k. So let's say that to write this recursive formula, we are going to start with k of 1, since we always start with the first term. And you might also see this written as k sub 1. But these mean the same thing. This is just the first term in this arithmetic sequence, which we call k. Then, once writing out what the first term is, we need a way to write out the pattern. So to find the nth term in our arithmetic sequence, we're going to take the term before that, which we say is k of n minus 1, and then we're going to add the common difference. Since all of these arithmetic sequences, they all have that common difference. And for this specific example, that common difference was 4, since we generated that sequence. And you can see from one term to the next, you're always adding 4. And both of these formulas can be a little bit confusing, but with practice and experience, they won't be so bad. So in the next video, we'll look at a couple different examples.